Alright guys, so this is the video for 9495B, and today we're going to use sine, cosine, and tangent to solve for side lengths. So we're kind of taking what we did yesterday and applying them today to help us find missing sides. It's a pretty cool process. Okay, now if you just, before we get started, okay, go ahead and in your calculator put, I don't know, let's just do tangent of 32. Okay, I just want to make sure everyone's in degree mode. And if you put tangent of 32 in your calculator, you should get roughly 0.62. Okay, so as long as you got 0.62, you should be in degree mode. Now, if you're getting something different, please go to your mode and then down and choose the degree mode because you're probably on radian mode. All right. So let's look at this triangle here. Okay, we want to find the value of x and y. So we know one side. So all we know is this angle measure, okay, and this side length. Okay, now trig allows us to do that. So if I take 32, this is going to be my reference angle. Okay, so I can go ahead and label my sides. So if that's my reference angle, this is my hypotenuse. This is my opposite, and this is my adjacent. Okay, now I'm just going to write SOHCAHTOA up here. Okay, so I have my opposite side. Okay, so notice I have two trig functions that have opposite in them. Okay, cosine, I don't need the opposite. Okay, so if I wanted to solve, I don't know, let's solve for x first. Okay, so if you solve for x first, you notice that x is our adjacent side and we know our opposite side. Okay, so you're going to look at these trig functions and ask yourself which one of these trig functions have O and A paired together. Okay, well, you'll see that the tangent does. See, O and A paired together. This is why I like writing it up here. Okay, so you're going to use the tangent function to solve for x. Okay, so you can say that the tangent of 32 degrees is going to equal, now remember tangent is opposite over adjacent, so our opposite's 11 and adjacent is x. So this is just what we did yesterday, but now we're putting some algebra in. Now if you put this into your calculator, you will get some value. Your calculator knows the sine, cosine, tangent of all these different angle measures. Okay, now we're not going to do that now because if we simplify too early, every time we use that simplification, it's going to make the error bigger and bigger. So we're going to wait till the very end. So to get x by itself, okay, the first thing I want to do is get rid of the fraction. Okay, so if I multiply both sides by x, those go away. I have x times tangent 32. That's going to equal 11. Okay, now to get x by itself, I can divide by tangent 32 degrees. Divide this by tangent 32 degrees, and what I get, those cross out, so I get x equals 11 over tangent 32. Okay, and now that I have x by itself, I can go ahead and just put 11 over tangent 32, or 11 divided by tangent 32 in your calculator, and you should get that x is roughly 17.6. Okay, and that's a side length. Okay, so it's not degrees, 17.6 inches or centimeters or feet or whatever. Okay, now I'm going to do the same process to find my y. Okay, so my y is my hypotenuse. Now think about this. Our x, or our adjacent side, this is rounded. Okay, all these are going to be rounded that we find. Not all of them, most of them. And so I want to keep using this O because it's not rounded, it's perfect. Okay, so I want to ask myself, which of these trig functions have O and H paired together? Okay, well, O and H paired together is right here, and that would be sine. Okay, so I could say that the sine of, once again, 32 is still our reference angle. That's going to equal, well, sine is opposite over hypotenuse, so opposite is 11 over hypotenuse is y. Okay, now it's back to what I did over here. Okay, to solve, I want to put y by itself. First thing I want to do is get rid of the fractions. So if I multiply both sides by y, those cancel out. I'm left with y times sine of 32 equals 11. Okay, and if I want to get y by itself, I'm going to divide by sine of 32 and divide by sine of 32. Now remember, sine of 32 is just a numeric value, and your calculator knows that value. Okay, so y is equal to 11 over sine of 32. And if I put that in my calculator, 11 divided by sine 32, I get y is approximately 20 let's round this up to 20.8-ish. Okay, so there's how you solve for x and y using trig. All right, so let's look at the next example. Okay, this is going to be the same process. So right now, my reference angle is the 61-degree angle, which is right here. Okay, so I'm going to label my sides accordingly. So this is my hypotenuse, this is my opposite, and this is my adjacent. Okay, I'm going to write so, ka, toa up top. Okay, easier for me to reference. Now, I know my opposite side. Okay, so I'm going to want to use this to find my x and y. So if I look up here, my opposite side's here and my opposite side's here. So I'm probably going to be using sine and tangent. Okay, now, let's find, I don't know, let's solve for x first. Okay, so x is my adjacent side, and I know my opposite side. So the two sides that I have or that I want are my O and my A. So I'm going to look up top and see, well, where do I see O and A paired together? And you can see O and A are paired together right here for tangent. Okay, so we're going to use tangent to solve for x. So I could say that the tangent of the angle measure 61 degrees is going to equal, well guys, tangent is opposite over adjacent. Okay, so that's 22 over x. Okay, now it's just doing algebra and solving. So get rid of the fraction first. Always get rid of the fraction first. So multiply both sides by x. Have x times tangent 61 equals 22. Remember, tangent 61 is some value, and our calculator has that value. So just divide both sides by tangent 61. Divide by tangent 61. Okay, I get x equals 22 over tangent 61 degrees. And if I put that into my calculator, just like that, 22 divided by tangent 61, I get roughly 12.2. Okay, now I want you to try on your own to see if you can get y. Okay, I'll walk you through the first step. Okay, so y is our hypotenuse. Okay, we know our opposite, so I want whatever trig function has h and o together. And if you look up here, we're going to use sine. Okay, so try to knock it out real quick and we'll come back to it. All right, so hopefully you tried to work it out on your own, and you should have got that y is approximately 25.2. All right, now that we've done a couple of examples, I want you to pause this video, okay, and try to do this triangle on your own. Try to solve for x and y using this triangle. All right, so hopefully you got it all worked out, and this is what you came up with. All right, so let's go ahead and label this triangle A, B, and C, okay, just to make this part make sense. Okay, now, once again, just for you to get extra practice, I want you to pause this video, okay, get x and y by its own, and then we'll do the rest together. Okay, so just another practice. Pause this video, get x or y, and we'll go from there. Okay, so hopefully you were able to do x and y. Now these are a little bit easier since our variable was on top. Okay, one less step algebraically, but you should have got that x is roughly 6.1 and y is roughly 12.6. Okay, now it wants you to find the sine of A, the cosine of A, and the tangent of A. Okay, now the sine of A, actually before we do that, let's just plug this in. So x is roughly 6.1 and y is roughly 12.6. That'll make our lives a little easier. Okay, now if I want to find the sine, cosine, tangent of A, that means this is our reference angle. Okay, so what I have labeled now, O, H, and A are still applicable. Okay, so the sine of A is opposite over hypotenuse, so 6.1 over 14. And if you put that into your calculator, you get 0.4-ish. Okay, the cosine of A would be 12.6 over 14. And when you put that into your calculator, you get roughly 0.9. Okay, and then tangent of A would be opposite over adjacent. So 6.1 over 12.6 gives you about 0.5. And that's rounded by quite a bit, guys. Okay, all right. Now, let's look at sine of B, cosine of B, and tangent of B. Okay, now, if I change my reference angle, my O and my A switch. Okay, so this is now my A, this is now my O. Okay, so now this is my reference angle. Okay, so sine of B is just opposite over hypotenuse, so 12.6 over 14, that's roughly 0.9. We're running out of room here. Okay, my cosine of B is 6.1 over 14, which is roughly 0.4. And my tangent of B is opposite over adjacent, so 12.6 over 6.1, and that's roughly 2.1 is what I got. Okay, so that's how you'd find sine, cosine, and tangent of the angle. Same thing we did yesterday. All right, let's look at example 4. Okay, so it says you're measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree. Okay, so angle of elevation starts at horizontal and goes up. So this is the angle of elevation. I'm going to draw it over here. Obviously, not nearly as neat. Okay, this is 59 degrees. This is 45 feet. And I'm trying to find my height. Okay, now, once again, this goes back to SOHCAHTOA. Okay, so, come over here. So if I label this, this is going to be my reference angle. So hypotenuse, opposite, and adjacent. Okay, I know my adjacent side. That's the value I have. I want to know my opposite side. Okay, so you're going to ask yourself, where up here in SOHCAHTOA do we see O and A paired together? Well, that is right here. Okay, so I'm going to use tangent. So I can say the tangent of 59 degrees is going to equal opposite over adjacent, so x over 45. Okay, let's multiply both by 45. Oh, I'm out of room. Ooh. 45, multiply both sides by 45. Those go away. So I have 45 times tangent 59 degrees equals x, and I can just plug this straight into my calculator. 45 tangent 59. I get roughly 74.9 or about 75 feet. Okay, I want you to try to do this on your own. We'll talk about it a little bit. Okay, so it says the angle of depression from the tower to the man is 40 degrees. So angle of depression, remember, that's horizontal downwards. So this is 40 degrees. All right, but now remember, if this is 40 degrees here, okay, alternate interior angles, this is also going to be 40 degrees because we know this and this are parallel. Okay, so if I want to redraw my triangle, I have right angle, 45, and I want to know how far I'm doing it, how far away I am, this is 40 degrees. So go ahead and work this out. Pause it and work it out. All right, so hopefully you attempted this on your own, and when you did, this is what you should have gotten. Rounded, you're about 53.6 feet away from the tower.